In question 1, we've got a stem and leaf diagram showing the number of hours worked per week by contractor Kiana for 38 weeks. We've got the quartiles of the distribution shown here, and we need to determine the values of W, X, and Y, where W is a value within the stem and leaf diagram. I will start with the lower quartile Q1. We know that to find the position of the lower quartile, we start by evaluating a quarter of the number of observations, so a quarter times 38, which is 9.5. Since this turns out to be a decimal, I round up, and I know that the lower quartile Q1 will be given by the 10th value. So looking in my stem and leaf diagram, I see that this is 19, and therefore we conclude that X is equal to 19. For Q2, the median, I will be evaluating a half of 38, which is equal to 19. And since this is an integer, I will take the midpoint of the 19th and 20th observations. So I'm doing the 19th and 20th values and divide this by 2. Now the 19th observation is 24, so the 24 plus the 20th observation over 2 will give me the median, and we are told that the median is 26. So this is equal to 26. So the 24 plus the 20th observation are equal to 52, which means that the 20th observation must be a 28. So looking at the stem and leaf diagram, the 20th observation is here, so it's 2, and the units digit is the W, which means that W must be an 8. So we've got W is 8. And we move on to Q3. Now for Q3, I will be evaluating 3/4 of 38, which gives an answer of 28.5. And therefore, the upper quartile Q3 will be given by the 29th value. Well, looking at the stem and leaf diagram, this is 37. And therefore, we conclude that Y is equal to 37. In part B, we are provided with the rule of determining any outliers, and we need to show our workings clearly to identify any outliers that Kiana finds. Well, let me start by evaluating the upper limit. So Q3 is 37 plus 1 times the interquartile range, which is 37 minus 19. This gives an answer of 55, so anything beyond 55 will be classified as an outlier. So looking at our stem and leaf diagram, the 59 and the 64 will be outliers. So what I need to say is 59 is greater than 55, and also 64 is greater than 55. And therefore 59 and 64 are outliers. In part C, we need to draw a box plot, and we will start by drawing the lower, the upper quartile, and the median. So this is the box. And then we draw the whiskers, which extend up to the maximum and minimum observations that were not deemed to be an outlier. So on the left-hand side, we go up to 14, whereas on the right-hand side, we go up to 51. And then we indicate with crosses the position of the 2 outliers we found in part B. In part D, we're given a formula for the skewness, and we need to evaluate this for this particular set of data. So the skewness in this case will be Q3, which is 37, minus Q2, which is 26, minus the Q2 of 26, minus the Q1 of 19, over Q3 minus Q1, which is 37 minus 19, which corrected 2 significant figures turns out to be 0.22. Kiana's new employer wishes to know the average number of hours per week she worked during her employment to help calculate the cost of employing her, and we need to explain why they might prefer to use the mean rather than the median number of hours worked per week. Well, we do know that the major advantage of the mean is that it takes into account every single piece of information. It uses all the data, or you could say that it includes all the outliers. Alternatively, we could be basing our answer around the answer we got in part D. We see that there is a positive skewness, and since the data is positively skewed, this means that the mean is greater than the median, and therefore this means that they would know the larger average they were expected to pay. In question 2, we've got an investigation between the GDP and the size of the population for a particular country. We've got a random sample of 9 years. We've got the population T millions and the GDP G billion dollars for each of these years summarized here. And we need to calculate the product moment correlation coefficient between T and G. Well, we know that the PMCC is given by STG over the square root of STTSGG. And I will start by calculating SGG, which is simply the sigma G squared minus the sigma G all squared over N. In our case, this is 3,624.41 minus the 144.84 squared over 9, which gives an answer of 1,293.4516, which means that R is equal to 40.25 over the square root of 1.29 times 1,293.4516. We'll plug this on the calculator and we'll get an answer of 0.98523 significant figures. We are then asked to give an interpretation of the product moment correlation coefficient. Well, we've got a positive answer here, which is actually quite close to 1. This means we've got positive correlation, which in context means that as the population increases, the GDP also increases. In part C, we are asked to find the equation of the least squares regression line of G on T in the form G is A plus BT. I will start by finding the gradient B, which we know is given by STG over STT. So this is going to be 40.25 over 1.29, which in exact form is 4,025 over 129, which correct to 3 significant figures is 31.2. Now to find the intercept, the A, I'll be doing G bar minus BT bar, which is 144.84 over 9, minus the exact value of B, which is 4,025 over 129, times the mean of T, which is 7.87 over 9. This gives an answer of minus 11.1906 ... and therefore we conclude that G is minus 11.2 plus 31.2 T. In D, we are asked to give an interpretation of the gradient of the value of B we obtain in the regression line. Well, we know that the gradient represents the increase in Y for every unit increase in X. In our case, we can say that for every extra million in population, the GDP increases by $31.2 billion. We need to mention the population, the GDP, and also the fact that we're talking about millions in population and billions in GDP. In EI, we need to use the regression line we just obtained to estimate the GDP in billions of dollars for a population of 7 million. Well, we know that this means that T is 7 as we are measuring the population in millions, and I will be substituting into the regression line. So G is minus 11.2 plus 31.2 times 7, which gives an answer of 207. So we are estimating $207 billion. In II, we need to comment on the reliability of our answer in part I, giving a reason to justify our answer. Well, to do this, I will start by calculating the mean of T. So T bar is 7.87 divided by 9, which is 0.874, which means that the data on which the regression line was calculated was based around the countries that had an average population of less than 1 million. Now we're being asked to estimate the GDP for a country with a population of 7 million, and since 7 is a lot greater than 0.874, this means we are well away from the center of the data, and hence the estimate is unreliable. In F, we are told that using the regression line from part C, it is estimated that the population increase of X million will give an increase of $0.1 billion in GDP, and we need to find the value of X. Well, based on the gradient of the regression line, we know that for every extra million in population, we've got an extra 31.2 billions of dollars. So we've got X extra millions. So we are having a 0.1 billions dollars extra, and we need to find X. So X is simply 1 times 0.1 divided by 31.2. This gives an answer of 0.00321. And the examiner is accepting anything which rounds to 0.0032. In question 3, we've got a grouped frequency table showing the lengths of 88 logs, and we are told that when a histogram was drawn, the 27 to 30 class had a width of 1.5 centimeters and a height of 4 centimeters, and we need to determine the dimensions of the bar for the 20 to 25 class. We'll start by drawing up a table. We've got the frequency, the class width, and the frequency density for the two classes. So for the 27 to 30, the frequency is 15, whereas for the 20 to 25, it's 35. Now the class width is the difference between the class endpoints, so it's 3 and 5 respectively, and the frequency density is simply the frequency divided by the class width, so 15 over 3 is 5, and 35 divided by 5 is equal to 7. Now let's put the dimensions. The width of the 27 to 30 was 1.5 centimeters, and the height was 4 centimeters, and we're gonna call the width of the 20 to 25 X and the height Y, and we're trying to determine X and Y. I will simply be using ratio and proportion. So if 3 units in width needed 1.5 centimeters, then 5 units will need X centimeters. So X is 5 times 1.5 over 3, which turns out to be 2.5. Whereas for the frequency density, we've got 5 needing 4 centimeters, and we say 7 will require Y centimeters. So Y will be 7 times 4 over 5, which is equal to 5.6. And therefore we conclude that for this bar, the width turns out to be 2.5 centimeters, whereas the height was found to be 5.6 centimeters. In part B, we are asked to use linear interpolation to estimate the median of L, and to do that I will start by evaluating n over 2, which is 88 over 2, which gives an answer of 44. So I need to interpolate the value corresponding to the 44th position. Now we'll proceed by finding the cumulative frequency. So I'm adding up the frequencies as I go down. So 19 plus 35 is 54, plus 16 is 70, plus 15 is 85, plus 3 is 88. And we can see that the 44th observation lies between 20 and 25. And I can therefore draw this diagram here to help me determine the median. So it's between 20 and 25. So somewhere along the way, we've got the median M. And we've got 19 observations up to 20 and 54 observations up to 25. These are the cumulative frequencies. And we need to interpolate the position for the 44th observation. So to do that, I'll be doing M minus 20 over 44 minus 19 is equal to 25 minus 20 over 54 minus 19. So let me write this down. So we've got M minus 20, the small opening, over 44 minus 19 is equal to 25 minus 20 over the 54 minus 19. This leads to M minus 20 over 25 is equal to 5 over 35. I will cross multiply to get that M minus 20 is equal to 3.571 dot dot dot, and therefore we conclude that the median M is 23.6. Now the maximum length of log Jill can use in her stove is 26 centimeters, and using linear interpolation she finds that X logs from the back will fit into her stove. We need to show that X is 62. Well, if we think about it, 26 is the midpoint of the 25 to 27 class, which means I will surely have those 19 and those 35 logs, and then I'm gonna have exactly half of the 16 because the 26, as we said, is the midpoint of this class. So x is simply the 19 plus the 35 plus a half of the 16. This gives an answer of 62 as required. We're then told that we will be randomly selecting 4 logs from the bag, and using x is 62, we need to find the probability that all 4 logs will fit into her stove. So we need to realize here that we are looking at sampling without replacement. So we start with 62 over 88 as the probability of the first one fitting in, and then it's 61 over 87, so we are dropping 1 each time. Then it's 60 times 86, and then it's 59 over 85. Now if I do this calculation on my calculator, I get 0.239. In part D, we are given that the weights W grams of the logs are coded using Y is 0.5 W minus 255, and we've got the summary statistics for Y, and we need to calculate the mean of W and the variance of W. Well, for the mean, I will start by finding the coded mean, which is Y bar, which is simply sigma Y over N, which is equal to 924 over 88. This gives an answer of 10.5, and we know that the mean is affected in exactly the same way as the coding works on the individual observations. So we've got that Y bar is 0.5 W bar minus 255. So 10.5 is 0.5 W bar minus 255, which leads to 265.5 is 0.5 W bar, and therefore we get that 531 is the mean of W, the W bar. Now for the variance of W, I will start by reminding ourselves the formula for the standard deviation of Y, which is simply the sigma Y squared over N minus the sigma Y over N squared and all square root. So in our case, it's going to be 12,862 over 88 minus the 924 over 88 squared and all square root. Plug this on the calculator, we get 5.9924 dot dot dot. Now when we talk about the standard deviation, the measure of spread, this is not affected by adding or subtracting a fixed number, so the minus 255 plays no role whatsoever in the standard deviation. However, the multiplier of 0.5 is indeed affecting the standard deviation, so we've got that sigma Y is equal to 0.5 times sigma W. So we found the standard deviation of Y to be 5.9924 dot dot dot, and it is equal to 0.5 times the standard deviation of W. So we get 11.9848 dot 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 to be the standard deviation of W. Remember, we're trying to find the variance, so we need the sigma squared W, which turns out to be 1,580 over 11, which is 144. In question 4, we've got two events H and W such that the probability of H is 3 over 8 and the probability of H union W is 3 over 4. Additionally, we are told that H and W are independent, and we need to show that the probability of W is 3 over 5. Well, let me start by the independence property. If H and W are independent, then the probability of their intersection is simply the product of their individual probabilities. Additionally, we know that the probability of H union W is the probability of H plus the probability of W minus their intersection, and since they're independent, this can be written as the probability of H plus the probability of W minus the product of the two probabilities. So we've got that the union has a probability of 3 over 4, which is equal to 3 over 8 plus the probability of W minus 3 over 8 times the probability of W. This leads to 3 over 8 is equal to 5 over 8 times the probability of W, and solving for the probability of W, get that this is 3 over 5, the probability of W, as required. We then have that the event n is such that the probability of n is 1 over 15, and the probability of h intersection n is the probability of n, and we need to find the probability of n dash given h. So let's start with the probability of h intersection n being the probability of n. This simply means that n lives entirely within h. It is a subset of h. So I could draw actually a Venn diagram to see what's happening. It should look something like this. We know that the probability of n is 1 over 15. We've got the probability of h, which is 3 over 8. So the only h part, which is this part here, is simply going to be 3 over 8 minus the 1 over 15, which is 37 over 120. We are being asked to find the probability of n dash given h, which is the probability of n dash intersection h over the probability of h. Well, the n dash intersection h means I want to be in h and outside of n, so it's this part here. It's the 37 over 120, and the probability of h is simply the 3 over 8, which was given. So this gives an answer of 37 over 45. In part C, we are additionally told that W and N are mutually exclusive. So this means they will appear as disjoint circles on my Venn diagram. They have nothing in common. And I need to draw a Venn diagram to represent the three events and all the associated probabilities. So my Venn diagram should look something like this. We can see that N is a subset of H, and W and N have nothing in common, so they appear as disjoint circles. Their intersection is empty. We have already established that the probability of N is 1 over 15. I could find the probability of H intersection W using the fact that they are independent, so it's the probability of H times the probability of W, which is 3 over 8 times 3 over 5, which is equal to 9 over 40. So for the intersection, I've got 9 over 40. Now to find the probability in the only H region, which is this part here, I'll do the probability of H, which was 3 over 8, and I will deduct the 1 over 15, which is the N, and the 9 over 40, which is the intersection with W. This gives an answer of 1 over 12, whereas for the only W region here, I'll do the probability of W, which is 3 over 5, and I will deduct the probability of the intersection 9 over 40. This gives an answer of 3 over 8, and the only missing region is the outside region. Well, I will simply use the fact that the sum of the probabilities should be 1, so this region here should be 1 minus all the rest, so 1 over 12 plus 1 over 15 plus 9 over 40 plus 3 over 8. This gives an answer of a quarter, so the outside region carries a probability of 1 over 4. In question 5, we've got a red spinner designed so that the score capital R follows the given probability distribution. We need to show that the expectation of R squared is 15.8. So I will simply be calculating this by considering the products of each value of R together with the associated probability and adding up all the pairs. So it's going to be 2 squared times 0.25 plus 3 squared times 0.3 plus 4 squared times 0.15 plus 5 squared times 0.1 plus 6 squared times 0.2, which gives an answer of 15.8 as required. Given also that the expectation of R is 3.7, we need to find the standard deviation to 2 decimal places. Well, we know that the variance of R is simply the expectation of R squared minus the expectation of R all squared. So this is going to be 15.8 minus a 3.7 squared, which gives an answer of 2.11. This means that the standard deviation is simply the square root of the variance, the square root of 2.11, which is 1.45. We now have a yellow spinner. The score is given by capital Y following the given probability distribution, and the third row here is the cumulative distribution function capital F of Y we need to write down the value of d, which is the last entry here. This corresponds to the probability of y being less than or equal to 6, which of course should be 1 because it accounts for every possibility. We know for sure that one of 2, 3, 4, 5, or 6 will appear, and therefore we can simply state that d is equal to 1. In D, we need to find the value of C in light of the fact that the expectation of y is 4.55. Well, I will start by saying that the sum of the probabilities shown here should be 1. So we've got that 0.1 plus 0.2 plus 0.1 plus A plus B is equal to 1. So 0.4 plus A plus B is equal to 1, and therefore we've got that A plus B is equal to 0.6. Now the expectation of y will simply be found by calculating the products of the values of y together with the associated probabilities and adding up the pairs. So it's going to be 2 times 0.1 plus 3 times 0.2 plus 4 times 0.1 plus 5 times A plus 6 times B. So we've got that the expectation, which is given to be 4.55, is equal to 1.2 plus 5A plus 6B, and therefore we obtain that 3.35 is equal to 5A plus 6B. I will take the equation we obtained before, that A plus B is 0.6, and multiply everything by 5 to get that 3 is equal to 5A plus 5B, and therefore I can deduct one from the other. We are essentially solving simultaneous equations here. So we get that 0.35 is equal to B, and I can proceed in finding A. So I will be substituting into A plus B is 0.6, and I get that A plus 0.35 is equal to 0.6, and therefore A is 0.25. Now that we've got the values of A and B, we can go back to the table here to find the value of C. Now C is the capital F of 5, which simply means the probability of y less than or equal to 5, which is going to be the sum of the individual probabilities. So we've got that C is going to be the 0.1 plus the 0.2 plus the 0.1 plus the A. So it's going to be the 0.4 plus the 0.25, which turns out to be 0.65. We then have Pavel and Jesse playing a game with these two spinners. Now Pavel will be using the red spinner, whereas Jesse will be using the yellow spinner. They take it in turns to spin their spinner, and the winner is the first one to have their spinner landing on the number 2, and that's where the game ends. We know that Jessie will go first, and we need to find the probability that Jessie wins on her second spin. Well, I will start by reminding us of the distributions for Y and R, the yellow and the red spinner. And we've got that the probability that Jessie wins on her second spin means that she took the first spin, she did not win. Then Pavel took their turn, they did not win, and then Jessie won by getting the number 2. So that means that we had a no 2 for Jessie, a no 2 for Pavel, and then a 2 for Jessie. So the probability of not getting a 2 for Jessie is simply 1 minus 0.1. The probability of Pavel not getting a 2, remember Pavel is using the red spinner, is 1 minus the 0.25, and the probability that Jessie gets a 2 is a 0.1, and plug this on the calculator to get 27 over 400. And finally, in part F, we need to calculate the probability that in a game the score on Pavel's first spin is the same as the score on Jessie's first spin. Now for this to happen, it means that for sure Jessie did not score a 2 in her first spin. Otherwise, the game will have ended and Pavel would never get an opportunity to spin their spinner. So for them to have the same score, it means we're looking at the 3-3, 4-4, 5-5, or 6-6 scenario. So it's going to be the 0.2 times the 0.3 plus the 0.1 times the 0.15 plus the 0.25 times the 0.1 plus the 0.35 times the 0.2, which gives an answer of 17 over 100. In question 6, we are told that the volume of oil in a bottle capital V follows a normal distribution with parameter mu being 100 and sigma being 2.5, and we need to find the probability that V is greater than 104.9. Now to do that, I will be standardizing, and this will happen by deducting the mean and dividing by the standard deviation. So it is a probability of Z greater than 104.9 minus 100 over the 2.5. So we're looking at the probability of Z being greater than 1.96. Remember that the table provided within the formula booklet speaks about the probability of Z being less than something. So I will write this as 1 minus the probability of Z less than 1.96. So going to the table of values, for 1.96 we can read off the probability of 0.9750, and therefore we've got that this is 1 minus 0.9750, which gives an answer of 0.0250. In part B, we've got 150 bottles, and we need to find the expected number of bottles containing more than 104.9 ml. So I will simply be multiplying the number of bottles, which is 150, times the probability of having more than 104.9 ml, which gives an answer of 3.75. We are talking about bottles. Do not worry about the fact that we did not get an integer. It's unexpected, it's a theoretical mean, so it's okay to get a decimal. In part C, we need to find the value of V to 2D P such that the probability of capital V being greater than V, given that V is less than 104.9, is 0.2801. So as always, I draw my bell-shaped curve here, centered at 100. We already know that we are certainly less than 104.9. So if the 104.9 is there, we know that on the right hand side it's 0.025, so on the left hand side is 0.975, and it is given, we know it's a fact, that we are within the shaded region, and we are asking what's the probability that I'm greater than V. Maybe V is somewhere here, so that's the probability. So the probability of capital V being greater than V, given that capital V is less than 104.9, is simply the probability that we are between the V and the 104.9, so the intersection essentially, over what we know for sure, which is the probability of capital V being less than 104.9. So I can write this as the probability of capital V less than 104.9 minus the probability of capital V less than small v over the probability of capital V less than 104.9. The probability of V being greater than V given V less than 104.9 is given to be 0.2801, and this is equal to 0.975 minus the probability of Z less than V minus 100 over 2.5, I'm standardizing here, over the probability of V being less than 104.9, which is 0.975. I will cross multiply, so I'll be multiplying the 0.975 with the 0.2801 to get 0.2730975 equal to 0.975 minus the probability of Z less than V minus 100 over the 2.5, which means that the probability of Z being less than V minus 100 over 2.5 turns out to be 0.7019 to 4 decimal places. So going to the probability table, I would be looking for a probability of 0.7019, which happens to be here, and the corresponding Z value is 0.53, which means that V minus 100 over 2.5 is equal to 0.53. If I cross multiply, I get V minus 100 is equal to 1.325. Therefore, V is 101.325, and we are being asked to give this to 2 decimal places, so V is 101.33. The examiner here is also accepting the 101.32.